This is an AI-generated fictional video intended for entertainment and education purposes. Welcome to the mechanical symphony of industrial transformation, where tons of raw, earthy cassava roots begin their journey on a massive steel conveyor belt into the facility. The harvest arrives straight from the fields, still covered in the rich soil of the earth, awaiting a process that will reveal the pure white treasure hidden within. Inside this ultra-modern facility, every movement is calculated, and every machine is part of a grand design to ensure the highest quality of the final starch product. The first step begins with a rhythmic tumble inside the dry rotating drum, where mechanical friction gently begins to loosen the outer layers of soil and debris. Watch as the vibration and collisions work in harmony, effectively stripping away the heavy impurities to prepare the roots for the intensive cleaning stages that follow next. Efficiency is key in this initial phase, removing bulk waste without the use of water yet, ensuring the factory environment remains controlled and the process stays sustainable. Suddenly, the atmosphere changes as high-pressure water jets ignite, signaling the transition to the washing stage, where pure water becomes the primary tool for deep cleaning. Each droplet is modeled with precision as it impacts the surface, creating a beautiful splash that carries away the remaining grit and sand from the root's crevices. A wall of water envelops the conveyor, ensuring that every single root is thoroughly rinsed and stripped of contaminants that could compromise the purity of the starch. The power of the pressurized spray reveals the true character of the cassava, turning the dark, mud-caked roots into clean, ivory-colored raw material ready for the mill. The used water is instantly captured and channeled into a filtration system, maintaining the hygiene of the production line and reflecting the facility's commitment to clean operations. Clean and glistening, the roots emerge from their bath, looking transformed and ready for the complex mechanical processes that will soon break down their solid structure. They march forward in perfect order, a steady stream of raw material that is about to undergo a radical physical change within the heart of the processing plant. Abrasive rollers spin at high speeds, carefully removing the outer bark while preserving the starch-rich heart of the root, a delicate balance of force and mechanical precision. The result is a sea of white flesh, a testament to the effectiveness of the initial cleaning and peeling stages in protecting the ultimate purity of the starch. Phase 1 is complete as the raw material is now fully prepared, sanitized, and ready to enter the high-energy environment of the crushing and milling machines. The industrial aesthetic of the facility shines through in every polished surface, emphasizing the sterile conditions required to produce a food-grade product of this exceptional caliber. One final rinse ensures that not a single speck of dust remains as the roots reach the end of their whole-form journey and face the blades. In this moment of stillness, the preparation ends, and the phase of destruction and extraction begins, unlocking the white gold hidden within every cell of the root. The second phase begins as massive blades of hardened steel accelerate to incredible speeds, ready to break the physical bonds of the cassava roots in milliseconds. Watch as the roots are sliced with surgical precision, turned into thin wafers that maximize the surface area for the subsequent extraction of the valuable starch granules. The vibration of the chopper unit echoes through the floor, a powerful display of industrial strength that makes short work of the toughest plant fibers in seconds. Peering inside the machine, we see a chaotic dance of fragmentation as the cassava slices are launched into the hammer mill to be pulverized into a fine slurry. The impact of the hammers is relentless, crushing the plant cells and releasing the microscopic starch granules that have been stored inside for months during the growth cycle. Water is introduced at this critical juncture, mixing with the pulverized roots to create a thick, milky slurry that acts as a carrier for the starch particles. This creamy mixture, known as starch milk, is the foundation of our product, containing the concentrated essence of the cassava in a highly fluid and processable form. The slurry rushes through a network of pipes, a river of white gold moving with purpose toward the separation phase where we will isolate the pure starch. The scale of the operation is immense, with multiple milling units working in perfect synchronization to process hundreds of tons of material every single hour of the day. Precision sensors monitor every aspect of the crush, ensuring that the particle size is exactly right to maximize the yield of starch while minimizing energy consumption. Even under extreme loads, the machinery operates with a smoothness that reflects superior engineering, a mechanical heart that beats for the sake of industrial excellence. Falling into the collection tank, the starch milk creates a mesmerizing pattern of ripples, a dense and rich liquid that holds the promise of the final product. Constant agitation keeps the mixture uniform, preventing the heavy starch granules from settling at the bottom, but maintaining a perfect suspension for the upcoming separation stages. The texture of the liquid is thick and luxurious, a concentrated blend of water and starch that represents the successful release of the plant's inner energy and nutrition. In the dim, artistic light of the factory, these machines appear as monumental sculptures, the heavy hitters of the production line that turn solid roots into liquid. The valve opens, and the flow is constant, a steady pulse of white material that flows like lifeblood through the veins of the starch processing plant. Massive electric motors provide the torque needed for this destruction, humming with a deep resonant frequency that defines the soundscape of this mechanical masterpiece. At a microscopic level, the cell walls are shredded, allowing the granules to escape their cages and join the flow of water in this industrial extraction. With the crushing complete, the slurry moves on, leaving the heavy grinding behind and heading towards the delicate and precise world of centrifugal filtration and separation. Phase 3 introduces the rhythm of separation, where a series of large centrifugal sieves begin the task of sorting the starch from the unwanted fibrous pulp. The slurry is sprayed against high-speed rotating meshes, using centrifugal force to push the liquid starch milk through while trapping the larger fibers on the surface. It is a beautiful sight as the fine starch milk passes through the tiny apertures, emerging as a refined liquid while the coarse residue is left behind. The fibrous byproduct, known as pulp, is separated with high efficiency, ensuring that only the purest starch continues forward into the heart of the refining process. The machines vibrate with a steady, musical rhythm, a physical manifestation of the sorting process that cleanses the starch milk of any remaining solid impurities. Physics takes over as centrifugal force acts as a master sorter, separating particles based on their density and size in a display of pure mechanical logic. Quality control is constant, as experts monitor the output to ensure the separation is perfect and the starch milk meets the strict standards for further processing. The discarded pulp is moved away, a valuable byproduct in its own right, while the primary focus remains on the whitening liquid that continues its journey. Multiple stages of filtration work in tandem, each one finer than the last, gradually honing the purity of the starch milk to a level of absolute perfection. The stainless steel mesh is a masterpiece of precision, designed to be durable yet fine enough to catch even the smallest speck of unwanted fiber or debris. Next, the liquid enters the decanter centrifuge, a powerful machine that will use extreme rotational speeds to further concentrate the starch and remove excess water. The mechanical power here is immense, yes, with the decanter spinning at thousands of revolutions per minute to create forces far greater than the gravity of Earth. Under this intense force, the dense starch particles are pressed firmly against the walls, effectively separating them from the lighter water and soluble proteins in the mix. An internal screw conveyor gently scrapes the concentrated starch from the walls, moving it toward the exit while the water is discharged through a separate port. What emerges is a thick, smooth cream, a concentrated form of the starch that is now nearly free of any plant fiber or external contaminants. Automation manages the entire flow, with computers making micro adjustments to the rotation speeds and flow rates to maintain the highest possible efficiency and product yield. Samples are taken at every stage, ensuring that the separation process is operating within the narrow margins required for a premium, high-grade industrial starch product. The concentrate is pumped forward, its journey far from over as it heads toward the hydrocyclone stage for the ultimate purification and whitening process. These pumps are the tireless workers of the facility, providing the pressure needed to move the heavy starch concentrate through the complex network of refining equipment. Every splash confirms the progress made as the material becomes whiter and more refined with every passing minute of this mechanical and chemical symphony. In this untouched environment, technology does the heavy lifting, ensuring a level of hygiene and consistency that would be impossible to achieve through manual labor. The numbers on the screen tell a story of success as the concentration of the starch milk reaches its target, ready for the final refining stages. Phase 4 introduces the hydrocyclone system, a sophisticated array of pipes and cones designed to achieve the final, most critical level of purification for the starch. These polished steel pathways lead the starch milk into a series of vortexes where centrifugal forces are used to strip away even the smallest impurities. Inside each cone, a miniature cyclone is born, a swirling vortex of energy that separates the heavy starch from the lighter proteins and soluble minerals. The pure starch is forced downward and out through the bottom, while the unwanted light phase is spiraled upward and removed from the production line entirely. With each pass through the hydrocyclones, the starch milk becomes brighter, shedding the last hints of yellow or gray to achieve a brilliant, snow-white appearance. The streams merge together in a manifold of precision, a collective flow of purity that represents the very best of what the cassava root has to offer. The environment here is clinical, with bright lights reflecting off every surface to emphasize the extreme cleanliness and the high-tech nature of the refining process. Automated actuators make micro-adjustments to the pressure, ensuring that the vortex within each hydrocyclone is perfectly tuned for the current batch of material being processed. On a molecular level, the protein and fiber are cast aside, leaving only the pure carbohydrate crystals that make up the high-quality starch our customers expect. The starch milk now flows into the final storage tank, looking more like liquid light than a food product, having achieved its maximum possible level of refinement. Its uniformity is absolute, a flawless liquid that is the result of 4 stages of intense mechanical and physical separation in this high-tech industrial facility. In the lab, every batch is verified, confirming that the hydrocyclone stage has successfully removed every trace of protein, oil, and mineral residue from the starch. The multi-stage washing process is a relentless pursuit of perfection, using dozens of individual cyclones to ensure that not a single impurity makes it through. Fresh, purified water is introduced in a countercurrent flow, meeting the starch at its cleanest point to provide the final and most effective rinse possible. Now, fully refined, the starch milk is pumped toward the dewatering section, the final step before the dramatic transformation from a liquid into a dry powder. The slow spin of the agitator ensures the refined milk remains perfectly suspended, waiting for its turn to enter the final stages of the production cycle. The data confirms our success, showing a purity level that is world-class, achieved through the power of physics and the precision of our hydrocyclone technology. These towers of technology stand as a testament to human ingenuity, turning a simple root from the earth into a highly refined industrial and food-grade ingredient. One last filter provides the ultimate security, a final check to ensure that the journey through the pipes has been as clean and pure as the starch itself. The symmetry of the design reflects the precision of the process, a beautiful marriage of industrial form and function that produces excellence in every single drop. The refining is complete, and the liquid starch milk now leaves this stage, heading toward the heat and energy of the flash drying towers. Phase 5 is the thapse, or drying tower, where the liquid starch milk undergoes a sudden and dramatic transformation into a fine dry white powder. First, excess water is removed to create a damp starch cake, which is then fed into the base of the tower to meet a blast. Thank you for watching our entire video. To make sure you don't miss any in-depth videos, please subscribe, share the video, and turn on notifications.